Okay, when an electron jump from n1 orbit to n2 orbit with the lambda, the wavelength can be written as 1 by lambda is equal to Rydberg constant into 1 by n1 square minus 1 by n2 square, 1 by n1 square minus 1 by n2 square. Okay, now here see 1 by lambda is also known as wave number. Reciprocal of wave number is known as reciprocal of wavelength is known as wave number. Okay, now while calculating lambda is equal to, we can directly write a trick for lambda 1912 angstroms by 1 by n1 square minus 1 by n2 square. Okay, now 1 by n1 square minus 1 by n2 square. Okay, here see we have to learn 5 tables. They are Lyman series, Balmer, Pascal, bracket, fund. Lyman, Balmer, Pascal, bracket to fund. Here 1, 2, 3, n is equal to 4, 5. Okay, now. And while doing this type of questions, we have to be very careful. Why we have to be very careful means they will give hydrogen atom. Okay, hydrogen atom in the second excited state. They will give second excited state. Okay, now they will give as a second excited state. Means we have to take n2 as a 3. They excited from the ground state means n1 is equal to 1. N1 is equal to 1 and n2 is equal to 3. While keeping in that equation, we can solve. But in the examiner may not give the n1 value. Examiner may not give the n1 value. He will give like the electron of hydrogen atom from a Balmer series jumped into the third excited state. Third excited state means n2 is equal to 4. Balmer means n1 is equal to 2. Okay, I repeat once again. Third excited state means n2 is equal to, third excited state means n2 is equal to 4, and from Balmer means n1 is equal to 2. Sometimes examiner may also not give in this way. The examiner will try to identify with the question. They will try to give it to the colors. For example, here see Lyman means a visible region. How to remember this? First we will learn about the dual nature of radiation. We learn the trick for this: gamma rays, X rays, UV rays, visible rays, infrared rays, microwaves, radio waves. See, I am repeating once again: gamma rays, X rays, UV rays, visible rays, infrared rays. Okay, now. First one is lying in the infrared. First one is lying in first one lying in the UV region. Second one is region is a visible region. Third is infrared region. Near infrared, far infrared. I repeat once again. See, first one is UV rays, then visible rays, then infrared rays, near, middle, far. Okay, in this way. Here see, if the question they give electron excited from an orbit which emit a visible color. Visible color means Balmer series means n1 is equal to 2. To an excited state of a third excited state means n2 is equal to 4. The word excited means very important. I wrote many times wrong due to this excited word without looking off, without seeing the excited word. Okay, now here see here see they will ask last line. Last line means they keep lambda 2 is equal to infinity. So they will ask lambda max for a Lyman series means Lyman means 1. Here lambda 2 equal to 0. Minimum means